So is the question. Once again I read out. For a rectangular cross section of width B and depth H is stressed up to Fy from both top and bottom up to H by 4. Find the moment carrying capacity of the section. A rectangular cross section of width B and depth H is stressed up to Fy from both top and bottom up to H by 4 distance, up to H by 4. Stressed up to Fy from both top and bottom up to H by 4. Find the moment carrying capacity of the section. Find the moment carrying capacity of section. Find the moment carrying capacity of the section. For doing the solution or for carrying out that moment, for carrying out the calculation of moment carrying capacity of the section, first we have to draw the diagram. So okay, cross section diagram and its stress variation that is mentioned in the question. So what it is mentioned? In the question it is mentioned as rectangle. So this is rectangle. In the question it is mentioned as a rectangle. So this is rectangular section of width B and depth H. Of width B and depth H. And here lies the neutral axis. Okay, so in the question it is clearly mentioned that from top and bottom up to H by 4 distance, it is stressed up to Fy. So it means the total is H. So this is H by 4. H by 4. So from top and bottom it is stressed up to Fy. Up to H by 4. And after that the variation is linear. So this is what the stress diagram that is given in the question. Now for this diagram he is asking us to find moment carrying capacity. So if you observe from top and bottom up to H by 4 and H by 4, the cross section is in plastic state, but for this depth it is in elastic state. So you can say this is a semi-plastic state. So in the introduction we have discussed about all the states, but we have derived or we have learned how to calculate the moments in elastic state, yield state and plastic state, but not semi-plastic state. Now let us see how to calculate the moment carrying capacity in semi-plastic state also. So this is H by 4. Obviously this is H by 4 and this is H by 4. This is how much? H by 2. So in this cross section throughout the depth H, this H by 2 is in elastic state and up the top H by 4 and bottom H by 4 in plastic state. So obviously for this H by 2 the stress variation is linear. Remaining it is constant. So now for this H by 2 we can consider it as a elastic state and use the same formula, that is M is equal to F into Z or M by I is equal to F by Z. But remaining we should not use that formula. If we take this compression area, so this is compression and this is bottom tension. So how much the compression C is equal to Fy into area. How much this area? H by 4 into B. So BH by 4. Bottom also the same. And if for the plastic state, we know that how to calculate moment carrying capacity. How to calculate force into lever arm. So how much the lever arm? Lever arm is nothing but distance between those two forces. So here this is the forces. So this is the lever arm. How much is lever arm? This lever arm in this case is nothing but C here. From here to here, this force will act exactly at the half. So this total is h by 4. This half is h by 8. So this is h by 8. And here also the same. This is h by 8. And this is h by 2. So how much total the lever arm is equal to h by 8 plus h by 2 plus h by 8. How much it is? 3h by 4. That is lever arm. So now to get the total moment, M is equal to M1 plus M2. So M1 is a plastic moment. So M1 is equal to C into lever arm. So how much C? Fy into BH by 4 into lever arm is 3h by 4. Total how much? Fy. So 3 Fy BH square by 16. 3 Fy BH square by 16. 3 Fy, so I'll write here. M1 is equal to 3 Fy BH square by 16. That is M1. Now what is M2? As I said, this zone is in elastic state. This h by 2 zone is in elastic state. So we can use that formula. M by I is equal to F by Y. So in that moment, M2 is equal to simply F into Z. Here Fy into Z. Z is how much? I by Y. For rectangular section, how much it is? BH square by 6. So here B H is how much? H is h by 2 here. H by 2 whole square by 6. Upon simplifying, how much we are going to get? Fy BH square. So it is 4. 4 into 6, 24. So Fy BH square by 24. So this is M2. So now to get the total moment M, we have to add these two M1 plus M2. So if we add this M1 plus M2, so how much we are going to get? So I am going to write here. So I am going to write here, see, M is equal to M1 plus M2. So M is equal to, I am going to add this. So in these two, can I take Fy into BH square as common? Yes or no? So if I take Fy into BH square as common, here it is 3 by 16. Here it is 1 by 24. If you take the LCM 16, 24, it is 48. So here 3 times, here 2 times. So 3 into 3, 9, 2. How much? 11. So 11 by 48. So finally we are going to get 11 by 48 Fy BH square. So that is the total.